In a medieval forest, ironmasters roasted wood without air and made something harder, denser, hotter burning than nature ever provided raw. They had no idea they'd started a 500-year conversation. Then coal arrived, and the old knowledge was buried. But in 1985, French researchers in Grenoble dusted it off, coining the word torrefaction, borrowed from coffee roasting, because the chemistry is genuinely the same. By 2009, Dutch engineers at ECN proved torrefied pellets could replace coal in power plants without changing a single burner. The technology worked, but it leaked energy like a sieve. Aromatic, chemically rich smoke, energy grown from the ground, paid for by the sun, vented straight into the atmosphere. For decades, no one could catch it. That was the scandal. Here's what the numbers actually say. Pilot units now produce pellets hitting 22 to 26 gigajoules per ton, matching thermal coal, while being carbon negative. The addressable market, $22 billion by 2030. That breakthrough belongs to one frustrated engineer. Andrés Cuervo-Piñera in Helsinki spent 6 years building a cryogenic rig from salvage freezers. And when Europe's 2022 energy crisis hit, his phone wouldn't stop ringing. The physics he used came from two impossible sources: Clarence Birdseye's 1940s frozen food science and 19th century perfume chemistry in Grasse, France, where coal traps captured jasmine terpenes without destroying them. For Janet Molitor in Iowa, this is an abstraction. Her switchgrass cooperative now ships pellets to a cement kiln in Indiana, displacing coal, generating carbon credits, adding $47 per acre to her net farm income. Cement production alone is 8% of global CO2, and its kilns run at temperatures only coal can reach. A carbon-negative pellet matching coal's heat is not incremental. It is the answer to the hardest problem in climate science. 8 countries are now racing to control the IP. Patent filings in cryogenic torrefaction jumped 34% between 2023 and 2025. The EU, US IRA credits, and IMO shipping rules are all pointing at the same fuel. In 20 years, networks of modular units could dot agricultural landscapes worldwide, functioning as distributed negative emission machines, pulling carbon from air, running the fossil fuel era quietly in reverse. But which future arrives depends on decisions being made right now. Subscribe if you don't want to miss the next breakthrough. We cover emerging tech most people won't hear about for years.